Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and today we are going to discuss briefly rational functions. Let's get to it, shall we? Thank you, Cranberries, for the awesome intro. Love it, love it, love it. All right, rational functions is a function of the form R of x equals p of x over q of x, where p and q are polynomials, baby. So you have a polynomial divided by a polynomial. Rational coming from or similar to what a rational number. Remember, a rational number can be written as a fraction, a and b, where a and b are integers. And of course, b cannot be equal to 0. Can't have the division by 0. So we're going to be looking at graphs of rationals today. We are going to start looking at the easiest of them, 1 over x. And here's a nice graph, f of x equals 1 over x. It's called a rectangular hyperbola. All kinds of good information here that we will get to in our example. It is there for your reference. I'm not going to read it to you, but you must know the shape of 1 over x, the basic shape of a rational function, or I should say the graph of a rational function. More good info here. We have a rational function a bit different, a little bit more complex than 1 over x, 2x plus 1 over x minus 1. And notice it's the same basic shape of the graph of 1 over x. We can use sign diagrams. We consider when, we consider as x goes to positive and negative infinity for the horizontal asymptote. We got the vertical asymptote. Again, we'll get to it. Here's some good information on finding the horizontal, but I think you'll see it's pretty straightforward once we do this. So first, find the asymptote of this function, y equals 6 over x minus 2 plus 4. So the vertical asymptotes, that is going to occur when we have a rational function and where we get the denominator of the rational, or when the denominator of a rational function is equal to 0, because then we would have division by 0, which is not possible. So if I set the denominator equal to 0 and solve, I know that is where the vertical asymptote is, because the function is undefined there. But more importantly, for vertical asymptote, it's when we are dividing by 0, or when it would force us to divide by 0. So I'm going to put this in here. I know it says sketch using technology, but we're going to give it a try just using, just doing it by hand and see how we do. Horizontal asymptotes, and we talked about this in class. I'm going to abbreviate that with HA if you don't mind. We need to consider the behavior of the function as x approaches plus or minus infinity. And usually you just have to consider one of them and then the other one falls right through. So the behavior, or you can think of it as the value of the function. Where is it headed as x goes to positive or negative infinity? So let's think of this. Y equals 6 over x minus 2 plus 4. Okay, so x is here, so we're going to forget about 4 for a second. Now as x gets really large in value, what happens to this term? So let's just do a real quick look here. So let's say x and y, and again I am just considering 6 over x minus 2. First of all, 6 over x minus 2. Okay, 6 over x minus 2. And we'll worry about the 4 in a second. If x is 12, 12 minus 2 is 10, and 6 over 10 is 0.6. If x is 102, 102 minus 2 is 100, and 6 over 100 is 0.06. Similarly, with 1,002, we would get 0.006, or 10,002, we would get 0.0006, and even a million. Let's do a million. 1, 1, 2, 3, 4, 5, 6. That's all I'm going to go because that's all I can figure. So that's going to be 0.0000006. And hopefully what you're seeing is as x gets greater and greater and greater, this expression gets closer and closer and closer to 0. So imagine what it's going to be out in the depths, in the coldness of infinity. It's going to be so close to 0, it becomes insignificant. Insignificant. Okay? Another thing we need to understand, if I have a constant in a numerator and a denominator that's going to infinity, the numerator is losing. It is insignificant compared to infinity, and that will always go to 0. Now, if I do consider the plus 4 right here, well, all of these zeros change to 4s, 4.6, 4.06, 4.06006, and so on. And hopefully you can see that as x goes to infinity, then y goes to, I'll say as x goes to infinity, y goes to 4. And the same exact thing is going to happen as x approaches negative infinity. So as I'm going to go ahead and put plus or minus infinity, and I think you can see we're still going to get a very small value of infinity, if you think of it that way, negative infinity. We're still going to get 0. Okay, so what we have here is our horizontal asymptote is y equals 4. Now, if you think about this, if I'm doing negative infinity, that is going to be a negative value, so this is it's going to be below 4. The value will be below 4. Like these were greater than 4, and negative going to a negative value, going to negative infinity. Sorry, the value of y is going to be 3.9999999, getting closer and closer to 4 from below. That becomes important in just a second. So let's put this in, 1, 2, 3, 4. Okay. F of x equals 4. Okay, now let's find the axes intercepts. Okay, so the y-intercept, let's do that. Let x equal 0, and I'd have 6 over negative 2. 0 minus 2 is negative 2. Plus 4, that's equal to negative 3 plus 4, which is equal to 1. So I got a y-intercept right there. And then my x-intercept is going to be when y equals 0. So I get 0 equals 6 over x minus 2 plus 4. Negative 4 equals 6 over x minus 2. Negative 4x plus 8 equals 6. Wonk. Negative 4x is equal to negative 2, and x is equal to 1/2. So I get a x-intercept of 1/2. And so we're going to sketch it. I have a horizontal asymptote, so as I know that as x goes to negative infinity, my graph approaches it there, and it also approaches it there. Okay. What about up here? Well, we can do it like 1 point, like 1. This is 1, 2, 3. When x equals 3, 6 over 3 minus 2 is 6 over 1 plus 4. Then y is 10, so that's way up here. Let's see, 4, 5. Let's see, 4, 5, 6, 7, 8, 9, 10. So 3. So I have it here. And so I know my curve is doing something like this, just because I know that I've got a vertical asymptote here. So it's going to go up, 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 up. And then it's going to go down, 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 down here. And then it's going to get my horizontal asymptote is going to go to the right, 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 right. Okay. And to the left, 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 left. And here, for our horizontal asymptote, we say that the function is approaching 4 from above as x goes to positive infinity. And you can see that here because it starts at 4.6 and then moves down, 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 closer and closer and closer from above. And if you think of negative values in here, we're going to be coming up, and it's going to get the value of the function is going to get closer and closer and closer to 4, like 3.9, 3.99999, 9999999, closer and closer and closer. So let's see how we did on a graph here. I've already set up the horizontal asymptote and the vertical asymptote. So let's graph the function. Just do a tab here, and I get 6 over x minus 2 plus 4. Graph it. Boom. Works in there very, very nicely. You can see our x-intercept of 1/2. Our y-intercept does appear to be 1 with our scale there. Our asymptotes fit nicely, and that's a nice little picture, and it's fairly close to our other graph. All right, so that'll do it. Hope you enjoyed it. We shall wrap this thing up mañana. And with that, I am